Hi there, this is Mr. Jones, and I'd like to help you with indirect measurement. Now remember that similar figures have corresponding angles that are congruent and corresponding sides that are proportional. Similar triangles can be therefore used to make indirect measurements. Alright, for example, in the illustration to the right, notice a tree casts a shadow that's 10 feet long. At the same time of day, a 5-foot tall woman casts a shadow that's 4 feet long. How tall is the tree? Well, notice that the two triangles that are drawn are similar triangles. We'll assume that the woman is standing perpendicular to the ground, and we'll assume that the tree is growing perpendicular to the ground. Well, the sun above then is shining down and shining at the same angle to the ground, to the horizontal. Okay? Well, if two angles of one triangle are congruent to two angles of a second, then the third pair of angles must also be congruent. So those two triangles have to be similar, and that means that their corresponding sides must be proportional. Okay? So let's call the unknown height of the tree x. If we were defining it, we would say x equal the height of the tree, and now we can simply use a proportion to solve for x. Notice the ratio of the smaller triangle to the large, let's use blue here, is 4 over 10. Right? This base corresponds to the base of the larger triangle, so 4 over 10 is going to equal 5 over x. And remember, that's called a proportion, one ratio equal to another, and when you have a proportion, we can find the cross product equal. Okay, so we'll multiply 4 times x, that gives me 4x, and that must equal 10 times 5, which is 50. Alright, well, once you know that 4 times x is equal to 10 times 5, then you can easily solve that by dividing each side of the equation by 4. 4 goes into 4 one time, and 4 goes into 50 12.5 times. Okay, so x, the height of the tree, must be 12.5 feet. Alright, well, that should be pretty straightforward. Why don't you go ahead and try a second example. Suppose in this instance a person that's 6 feet tall casts a longer shadow that's 10 feet long. And the shadow of a flagpole measured at the same time of day is 35 feet long. Alright, see if you can set up a proportion. You may want to draw a diagram as we had above, and then calculate the height of the flagpole. And when you're ready, hit continue. Okay, well, let's see how you did. Here's mine, if you will, not the most precise drawing, if you will, but close enough for government work. Right, I have a 6-foot tall person casting a 10-foot long shadow, so I have a right triangle with legs of 6 and 10, and adjacent to it I have a flagpole of unknown height. Right, there's my flag, casting a shadow that's 35 feet long. Okay, so I can set up a proportion. The ratio of the corresponding sides is 10 to 35, and that must equal 6 over x. Okay, so then we find the cross product. We cross multiply 10 times x. There's 10x should equal 6 times 35. Well, simplify that. 6 times 35 is 210. Then divide each side of the equation by 10, and that gives you x is equal to 21 feet. So this particular flagpole is 21 feet long. I suppose I should have had the stripes be red and the stars be blue. How's that? Alright, well, that should give you a pretty good idea then of how to use similar triangles to make indirect measurements, and I urge you to work carefully and work well.